So we have shrinked the size of the original geographical area into this piece of paper, and we have a multiplier here that each centimeter of this map is will correspond to some 1,000 kilometer. So like if you get any centimeter or any distance in centimeter here in map, you can tell that this place and this place is this kilometer apart. So every time when you have some data like the area is this, the perimeter is this, the total coastline is this. So every time when you measure something on this map, and let's say it is it is some centimeter like 2 or 3 centimeter, and the multiplier here is 1 centimeter is x 1,000 kilometer or x kilometer. So we what we in order to find the exact length, we multiplied the centimeter value with that x. So this x is kind of multiplier. It's x as a multiplier, which gives you the original or exact length from this map. So similarly, in ratio, what we do, we make a greater, bigger system, bigger number system into smaller number system. Like I'll give another example here. Let's say a person has a salary of 80,000, and he spends some money on different modes. Like he spent 15,000 for house, 10,000 for recreation, 5,000 for food, and similarly 10,000 for travel. So this is how he's spending money. So rather than writing in entire 80,000, we can just write 80, 15, 10, and even 5, 10. So we can write these smaller numbers, we can add, and we know whatever the number I'll get, like if after all the expenditure, if I'm getting 2, so the total saving will be 2 into 1,000. So we reduce the salary by 1,000. So that's why the multiplier here is 1,000. Multiplier here is 1,000. All the calculation that we want to do with this salary, we will not write the K part. We'll not add the 30 here. We'll just write 15, 10, the numbers, and we know each number here, and it has a unit 1, and 1 corresponds to 1,000. 1 is 1,000. So this is how we identify the multiplier. So here it was like quite easy that you reduced the situation and by dividing the number by 1,000, and you did all the calculation in that that number, and finally you can go back to the original figure by multiplying it by 1,000. So this is how we use the concept of multiplier. So we reduce some system into smaller system, we find out what is the multiplier, and we do all the calculation in the smaller system, and then go back to the original system by multiplying it with multiplier. So this is the concept of ratio. Oh, but when we start learning ratio, we try to we basically compare two quantities, or we compare two numbers in terms of ratio also. Like let's say there are two person A and B, A and B. A has a salary of 30,000 and B has a salary of 20,000. So when we say what is the ratio of A and B, what is the ratio of salary of A and B? Ratio of salary of A and B. So when I have asked this, what is the ratio? So here the ratio means we need to take the least integer possible with which we can relate or we can compare the salary of A and B. So here A is to B is 30,000 by 20,000, and after dividing it by 10,000, we get what? 3 by 2, and then we write A is to B is equal to 3 is to 2. So when someone is asking the ratio, by default he is asking the ratio or the comparison in smallest possible integer. Smallest possible integer. By default, he is asking about that. But not like if it represent the same ratio by 6:4, it's not wrong. It is still the ratio of these two salaries. It's still the comparison of these two salaries. So these two ratios are almost same. Why I am saying almost same? Because otherwise everyone can tell that these two ratios are same. But here I am saying it is almost same. It is same on the basis of comparison that we are doing. But the multiplier here and here are different. So for this ratio, multiplier is what? With this ratio, multiplier is 10,000. And when we doubled it, when we doubled the ratio, like it is, if it is 6:4, the multiplier is 5,000. So now you know when we multiply some ratio by another number, both sides, like if there is a ratio 6:5, and if there is another ratio 18:15. So we know these two ratios are same, but while solving problem, we know that even if they are same, they will have different multiplier. If the multiplier of this is x, so multiplier of this ratio will automatically be x by 3. Okay, so it's got multiplied by 3, so the multiplier will get divided by 3. So the point is that you don't know, or that you might have not seen it before, that we always think that these two ratios are same, but they are not exactly same. They are almost same, and there's a difference between them in terms of multiplier. So we use ratio to compare two objects, and we make those objects into smaller parts, and then we say in the smaller numbers that ratio of salary of A and B, or sale ratio of sales of A product and B product is this is to this. So the foremost use of ratio is comparing two products. So here I'll tell you some of the way by which we can represent ratio. Uh, like not every time we'll get ratio presented in something is to something. They may represent ratio in different way, and you all should know that how many ways, or in how we can convert the representation into exact ratio way. So other representation of ratios into exact ratio way. So let's say if someone is says 2a is equal to 3b. So this is also a way to represent ratio. And how do we get exact ratio, or ratio in our this notation? How do we get it? We just do it like A is to B, B comes to this side, and the 2 goes to other side. So this is how we convert this into this, and we can say 3 is to 2 is the ratio. If someone says that 20% of A is equal to 30% of B. So this is also a way to represent ratio. So you might get this representation also. Here also we can easily say that 20 by 100 into A is equal to 30 by 100 into B. And then we again do it like A by B is equal to 3 by 2. So we got the ratio again 3 is to 2. So this is also a way, and you can just get the ratio from this statement only without doing these steps. If you'll smart, it will be smart. Like 20% of A is 30% of B. By seeing the statement, you can easily say that A is a greater quantity. And since it is in multiplication format, so it will always be in the percentage ratio only, like 30 is to 20. And that is 3 is to 2. One can also represent ratio like this. Half, 1/3 of A is equal to half of B. Half of B. So now you can easily convert this into ratio. It is again A by B is equal to 3 by 2, and which is 3 is to 2. I can also say that A is 50% more than B. So this is also a statement which can be given instead of ratio. Where we'll have to convert this into ratio. And if A is 50% more than B, then A is 150% of B. That means A by B is equal to 3 by 2. Somebody can also say in this way that B is 66 2 by 3% of A. So if you are pro with percentage, you can easily calculate it again. A is to B is equal to 3 is to 2. And one can also say in this way, A is to B is equal to half is to 1/3. So again, if you want to convert into this ratio, we'll multiply this by 6. Why 6? Because 6 can be divided by 2 and 3 also. So 6 is the actually multiple of 2 and 3 also. So if you multiply this, you'll be getting 3 is to 2. So these are the ways, these are the some way with which one can represent ratio or represent ratio. You should be able to convert this statement into ratio. And there may be some other ways also, but it will be based on similar structure, like either it will be based on percentage or fractions or some other form of multiplications. So once now you know about the ratio, that ratio can be used in comparison. So now what type of question you will get in ratio? So the first type you'll be getting is merging the ratio. We'll be talking about this later, because what I'm taking here, I'm taking the smallest or like most used example of merging. But in the chapter of mixture or in the chapter of allegation and mixture and allegation and other chapters, we will be using this concept extensively if we'll be able to understand that. So let's say here there are two quantity A and B whose ratios are into 2, 3 is to 2. And then again B is to C is in ratio of 5 is to 6. And if someone asks that what is the ratio of A is to C, or they can also say what is the ratio of A is to B is to C. So basically in both the cases, what you have to do is you have to merge these two ratios. And what is the meaning of merging these two ratios? So I'll tell you here. What we know that this ratio will must have a multiplier. Let's say the multiplier is x. So if this ratio has a multiplier x, this ratio will have a multiplier, a different multiplier, of course, y. Why it should be different? Because here 2 gets multiplied with x to get b. So again, we cannot use the same x to get multiplied with 5 to get b. So x and y must not be equal. So in order to merge these two, we'll try to make b or reach b, reach b to a position so that the value of b will be same in both of the ratios. So what we are seeing here is that the common multiple of 2 and 5 is 10. So we'll make this ratio reach a value where b is 10. So we'll multiply it with by 5. So I'll be getting 15 is to 10. This is the ratio of A is to B. And I'll multiply this by 3. So that we'll be getting 15 is to 18. So once the multiplication is, sorry, 2, I'll multiply it by 2 so that I'll be getting 10 is to 12. So after doing this, what we can see here, or what do we see here is that both the value of B at the both places is 10. So now we can confidently say that the multiplier of these two ratio is same, which is Z. And now this ratio has been merged. This is the situation we say where the ratio is merged. So after merging the ratio, we can finally tell what will the ratio of A is to B is to C. So A is to B is to C is 15 is to 10 is to 12. And then we can further find out what is the ratio of A is to C, which will be same as 15 is to 12, and we can reduce it by dividing it by 3, which is 5 is to 4. So this will be the ratio of A and C. So this is the first thing that you need to know here is, and we will be using this concept, the merger concept, in solving very difficult problems or some problems where you will, if you use the traditional method, it will take too much of your time. But by using this concept, you can solve those questions in seconds. So we'll be discussing this later, but let's go to the different part of the problem with ratio. So now we know that the problem may come as you'll be given some ratios, like they can give you the ratio of A is to B is to C as 5 is to 4 is to 7. And they will give you one data, a data, it could be anything, like first, the difference between salary of C and A, ये salary का ratio है, this is the ratio of salaries. Difference between salary of C and A is 24,000 rupees. Or they can give you a different data, like A earns 12,000 less than E. Or they can give you some other data, like the average of A and C is 72,000 rupees. And they can also give you like the total salary by all three, the total salary of A, B, and C is 192,000 rupees. So they can give you any statement, and they can give you some other type of statement also. And then finally they can ask a question. So this will be the typical structure of these type of problem. There will be a ratio given in this format of, or any of the format give which I have already mentioned above, or any other format. They will give you a ratio. They will give you a data, and finally there will be a question that find the salary of C or A or B They can ask any question. Okay. So this what is the question is not very much important here, because whatever they are asking, you can only tell if you know the multiplier. So the hidden question is find the multiplier. So all these questions will be based on finding the multiplier. So see, I told you that this problem that I am discussing right now can be iterated and made into multiple problems. So the first type of change which you can do is by the way in the method of representing ratio. So I just ask in a straight format that this is the ratio, but they can give you the ratio in any of the earlier discussed way, like they can ask you like 3a is equal to 2b is equal to 3c. So they can give you a ratio in this way also. They can also give you a ratio that b is two third of a, which is 4/5 of c. So all these ways are there to give you ratios. So this kind of complexity may be there. Then I told you that they will give you a data, a certain data, which will actually given or which will give you to calculate the multiplier. So there are variation of that too also. Four of them I have written here, but we can make multiple way or multiple arrangements to give you these data. And finally, the question will ask you any of the thing. So they can ask the salary of C, salary of A, salary of B, salary of A and B, salary of A and B together, like A and B and C together. So whatever the question is, that will be solved through multiplier. These data will give you the value of multiplier, one of these data, whatever is given there. And here you will be getting the ratio in any of the format. That will depend on the exam or the question setter in how much difficulty he wants to keep you in. So so let's go back to the original problem here. The ratio is 547. And let's take all the data here one by one. I'll tell you that any of these four statements can give you a multiplier. So the first statement says the difference between salary of C and A. C and A is 24,000. So I can just see that the ratio of A is to B is to C is 5 is to 4 is to 7. And we see that the difference between 7 and 5 is 2. So what they are giving me through first statement is the value of 2 is what? 24,000. So it implies the value of 1 is what? 12,000. And with this, I got the value of multiplier. So now, if they are asking the salary of C, I can just multiply 7 into 12,000 and I will get the value of salary of C. Second statement says A earns 12,000 less than B. So, oh, sorry. B earns 12,000 less than A here because the ratio says that A is earning more. So B earns 12,000 less than A. So we can just see that B earns how much less in ratio term? 1. So the value of 1 is here. It is given 12,000. So now we know the multiplier is 12,000, the same multiplier. The third statement also gives you the average of A and C is 72,000. So what do we see here is the average of A and C, which is 5 plus 7 by 2. 5 plus 7 by 2, which is 6. And the value of 6, 5 plus 7 by 2, which is the average here, which is 6. And the value of 6 is 72,000. So I can calculate the value of 1, which is 12,000 only. And once I'll get the multiplier, I can find out anything, whatever they are asking. Similarly, if they are asking they are saying that total salary of A and B and C is 192,000. So I'll calculate the total salary here in the ratio, which says 5 plus 4 plus 7 is 16. And the value of 16 is 192,000. It implies value of 1 is 12,000. So I got the multiplier here also. I got the multiplier here also. So we can get the multiplier with any of these four statements. Sometimes they might give you such data with which you might not calculate the multiplier. In that case, you can say the problem cannot be determined or data is inadequate. So, but most of the time you'll be getting such data with which you can find the multiplier very easily. So this particular problem that we have discussed, you will find most of the problems you can solve through this only. Okay. The next type of problem will be based on change in ratio. So in order to learn that how the ratio changes, let me give you an perspective here. Let's say the salary ratio of A and B, is 5:3. Okay. And no other statement is given. I mean, there is no statement which is given there to check or guess the multiplier. So can you tell what is the salary of A? Now just tell me no. If you cannot. Okay. Elastica, are you there?
Yes, sir.
Can you tell the salary of A? बोलो नहीं. बोलो
नहीं, sir.
क्यों नहीं? क्योंकि केवल रेशियो की फिगर दी है. There is no statement there to help us to find out the multiplier. तो रेशियो से ओरिजिनल पे जाने के लिए हमें मल्टीप्लायर चाहिए होगा, which is not there. Not been given any statement or hint to find out the multiplier. Okay. So if the salary ratio is 5:3, so we cannot tell anything about the salary, and the salary can be anything. Like if this can be 500 and 300, the salary can be 5,000, 3,000. The salary can be 1,500 and 900. It can also be 5 lakhs and 3 lakhs. Who knows what is the multiplier? Now, if it is not given or the hint is not there for multiplier, now the statement is there, another statement is there that salary of A increased by 500 rupees. And the question which has been asked here, what is the new ratio of A and B? I mean the ratio of salaries of A and B. So can we tell that what will be the new ratio of A and B? बताओ मुझे. Can we tell, Ruba? Tell me. Can we tell if just this statement is given that the ratio of the salary of A is increased by 500, what is the new ratio of A and B? Ruba?
No, we couldn't predict that.
We cannot tell because it will be different for different value of A. So since
Yes.
we don't know the exact value of A, we cannot pick a certain value of A here. And if we keep, if we'll add 500 to all these places, like if we'll add 500 to this place, the new salary will be 10:3. If I'll add 500 with this place, the new salary will be 11:6, I think. If we'll add 500 to this, the new salaries will be 20:9. So every time with the different value of A and B, we are getting different ratios. So if some real number or original number or the number in which the salary will be discussed, if in that scale the growth is there, you cannot exactly tell that what will be the new ratio, because we are not sure the value of A and B. And so with every other value of A and C, A and B, you will get the different ratios, final ratio. But if someone asks you, if someone asks you that in the same case, if salary of A gets doubled, then what will be the new ratio? Ratio of salary of A and B. Tell me, can we tell now?
Sir, is it 10:3? We can see.
Exactly, we can tell because the salary of A is getting doubled. So this gets multiplied. So whatever the value will be for A, if we'll check the same thing in all the different values that we have taken for A and B, every time we will get 10:3 because the value of A gets doubled. Here not, it is not the case of addition, but the case of multiplication. So the idea here we got is we can accommodate multiplications and division. And divisions in ratio. We can accommodate, we can find the new ratio. So now when you know this, and there is another statement here which says, there is another statement here which says, if salary of A increased by 20%, then again new ratio of A and B. क्या होगा? What will be the new ratio of A and B? So tell me someone, can we calculate now the new ratio of A and B?
Sir, can't be determined.
Can't be determined. क्या नाम है तुम्हारा? What's your name?
Sir, गरिमा.
गरिमा. बताओ क्यों? तुमने can't बोला कि can भी बोला?
Cannot.
Can not बोला. क्यों?
Because sir, रेशो में A का वैल्यू कुछ भी हो सकता है. We do not know कि 20% कितना आएगा.
But 20% will be based on value of A only. So if A is 500, the 20% will be 100. If A is 1500, 20% will be 300. If A is 5000, 20% will be 1000. So here the 20% value of A will depend on the value, whatever the value of A will have. It's not absolute, it's dependent value. And increase of 20%, we can represent this as a multiplier. Like I have told you, like 100 times that percentage increase or decrease can be represented as multiplier. बताया कि नहीं?
Yes, sir.
So what is the multiplier of 20% increase?
6/5.
Yes. So the multiplier, I mean to increase 20%, we can just multiplier of 20% increase. We can just multiply 6/5 to any number in order to increase it by 20%. कैसे? 20% is 1/5 of the number, and if you'll add 1/5 of any number, you'll be getting 6/5. And in previous example, I already have established we can accommodate multiplication and division in ratio. There is no problem in it. So in this problem, in this question, we can tell what will be the new ratio. गरिमा समझ में आया? The previous ratio is A is to B, which is 5:3. And if you increase 20%, A, you'll be getting 6:3. And we can represent the same as 2:1. Because in general, if ratio is asked, we will represent it as the smallest term. Hello, Garima, are you there?
Yes, sir.
So why did you say that cannot be determined?
सर एक
Because
बार
sir,
रिपीट कर दो.
एक second. So here the question is there are two quantity A and B, which is in ratio 7:5, and A increased by 10%, B decreased by 10%. So here the change is there in percentage term, and I have already told you that percentage change is like based on whatever the value of A and B is there. So 10% of A will change with the value of A. So if A is 70, 10% of A is 7. If A is 700, 10% of A is 70. So it will keep on changing. And since it will keep on changing, it's not an absolute value, it's not a constant value. We can accommodate it into the ratio. So if someone is asking what is the new ratio, we can just accommodate that. We can just accommodate that by doing multiplying it by the multiplier, or a simpler way is to, I can just write a value of A and B. I can take 70 and 50, and then I'll say the new ratio will be, if A is increased by 10%, it will become 77, and B is decreased by 10%, it will become 45. So the new ratio would be 77:45. So percentage change can be accommodated. And in how we can do the same thing with multiplier. So if A is increasing by 10%, so 7 will get multiplied by 11/10. You know the multiplier of 10%. And 5 is B is decreasing by 10%, so it will get multiplied by 9/10. So finally, in this case also, you will get the same ratio, which is 77:45. So this is how we accommodate the change in the ratio. So one of the very basic thing that I generally ask to all of you, like, I'll give an example of three people's salary ratio. One A is to B is to C, which is 7:3:5. Let's say this is there. Okay. And if I'm asking you that, and if I'm telling you that the average of these three average of these three is 60,000. So first of all, tell me what is the salary of C? Salary of C क्या होगा? What is the salary of C? If average of these three is, so it is the example of the previous question only. In a way, you will be given the ratios. With the statement, you will be given a statement with which you can find the multiplier. And finally, there will be a question which you can get or tell the value by multiplying the concerned value with the multiplier. So here the average of A and B, A, B and C in ratio term, what will be there? What will be that? Average क्या होगा A, B, C का in ratio term? 6 की 5. 5 ना? So, so we know the average is 7 plus 3 plus 5. Just 7 plus 3 plus 5 divided by 3. And if you studied the average chapter, you can just tell that the average will be 5 only. So the 5 value is 60,000. So you can be a little smart here. You don't have to calculate the multiplier here. Why? Why you don't have to calculate the multiplier? Because they are asking the value of C, which is 5 only. So you don't have to calculate this, although I have written the multiplier here by this statement, but you don't have to calculate even because the salary of C is 5 only, even in the ratio term. So whatever is the average, it will be the salary of C because the average value is 5 only. So the salary will be 60,000 only. But my question was not this. I just give you an example. Now, in this question, if we want to add D in this group, I mean, I want to merge the D value in this ratio. And I told you that D earns 48,000. So what should we write here? What should we write here? Tell me. D earns 48,000. What should we write here?
4 it's to 4.
Exactly.
4.
Yes, very good. So you know how to accommodate a number into ratio figures if we'll just snatch the multiplier out of it. So you know that this ratio has a multiplier of 12,000. I removed 12,000 from 48 and we are left with 4. So I can keep these 4 into this. So now everyone is quite smart. Know the value of, to know the importance of multiplier. And later you can find some problems in the chapter of ratio while solving problems. You can ask that in doubt. And in next class, whenever we'll take the next class, we'll be doing extensive problems on, not extensive, like we'll be doing some good problems on merging the ratio. So till now, if I'm not teaching you right now, then you can do it by simple algebra method or whatever method you can do. Okay. So till now you do it by that way. After the second class, you can use this ratio merger technique, which is very unique and I'll say awesome. Okay.